Hi, everybody. I'm really sad there's not still a seesaw here. I was going to have some fun with that, but here we are. So thank you for joining me today. I'm here to talk about some of the work we've been doing in battery energy storage system security. To tell a little story of how this work came around. In the last few years, the US has been doing amazing things with battery energy storage for the electric grid. I'll just say BESS from now on. They've been installing things all over the place in hospitals, looking at backup generation, looking at segmenting loads during different outages as well. Batteries have been providing us a lot of resources to help keep the lights on during large events. But that being said, there's a surprise about a lot of it to people that the majority of our supply chain for battery energy storage in the control systems and other PCs is actually from China. As much as we're providing a lot of critical resources for different loads, yes, 95 to 100% of the components available for these resources are from China and either have a PRC, made, owned, derived control or software component. That's kind of a big deal, but to tell a story of where we got, a few years ago, how this work really started to come about. I've worked in renewable energy and solar integration for a number of years. I worked as an interconnect engineer as well. I used to go to the renewable energy conferences all the time. A few years ago, I'd gone more into cybersecurity and hadn't been to quite as many. Came back to the industry, was walking the show floor a couple years ago at this conference, and as you can see from the vendor floor map, was starting to see a pretty huge change that had happened in the industry, or a change that had evolved. When I was looking around, I really realized we used to name companies things that, hi, we're definitely not from China, we're big boy American Solar, or something like that. But in the end, the majority of the systems were. I think one big telling fact was even when I went through the vendor show floor map, almost everything, there was about 50 different vendors whose first name was Shenzhen. And I was like, okay, that's probably a big sign that this industry has really gone towards Chinese supply. A second story on there, about a year and a half ago, there was some media releases about a particular battery company called CATL. They'd been installed on a few military bases and a few other locations, and as people discovered, partially because there was a selfie taken during one of the installations and cattle was written behind the command's head, but at the same time, they started to see okay, this is really actually potentially a problem. We have this infrastructure everywhere on critical loads. The picture on the left, just to explain on the slides, I was taking pictures at this conference of the size of different booths, because I think it's amazing how much money people spend on their booths and how big they are. But this one was for CATL, for cattle. They actually had a full-on energy storage system and a container sitting there as well. And the booth was probably about the same size as my house and probably cost more as well. So in the end, if everyone knows how much booths cost, this was a big indicator that getting rid of these entities, even if they're on ban lists or anything else, was actually going to be pretty difficult. So roll on to the question that happened around, well, can you tell us everywhere these systems are? Because we really need to work out a plan for this. We might be looking at a rip and replace order or something else. And my answer was, well, I'm not going to spend the money looking for everything that you wanted to see. The answer is it's everywhere. They're the biggest supplier in the country. We need a different plan. And so that's really what this story is about here, is the work that we've been doing on this to try and secure the system, the deployment efforts we're doing, and some of the solutions we've put in place already to try and solve this problem. So it's complicated. When we look at batteries, we talk a lot about battery cells in particular. You hear people talk about the electrochemistry, the critical materials that we're looking at importing. What you don't hear people talk about as much is the inverters, the control components, the PCs that connect it to the actual grid. That was one of the things we took a focus on first. We started going through these systems and basically saying, what are the bits that are most important from a cybersecurity and physical security perspective? Looking at what talks to what it controls, what safety actions it does, and then rank those basically in a way that we could work through and do a systemic analysis of the whole thing to be able to apply the solutions that we were looking at. But we also did this. I started to go through and count how many suppliers were involved as well, just because I wanted to have a big number to see it's not just one, it's hundreds. And so when we looked at things like the BMS, the PCS, and other components, we were starting to see the level of supply that they were talking about here was enormous. So when you look at inverters, if you look at California actually has a really nice approved list of who you can buy and still get tax credits with inverters. There's about 1,700 inverters on that list and about 73 different vendors, and yes, they all use Chinese components. So that's a big number. We're not just banning one at this point, it's whack-a-mole. So how do we actually deal with that is a big goal of all this work. It's important. We like batteries. We think they work really well. One of the other important pieces of this work was to say, if we actually did try and pull all of this battery energy storage off of the system, if we're saying it's bad, get rid of it, drop it now, we'd actually probably damage the reliability of our grid rather than help it at this point. Because things like in Texas and California during various hot and cold weather events have been using that storage to essentially apply essential load and keep the lights on as well. I think during Storm Uri in Texas, there was a gigawatt of batteries that ramped up to try and keep part of the system online. During a heat event in California, there was an emergency dispatch that was keeping parts of SoCal online. There's a lot going on here where the systems are really helping us. We don't actually have that much to replace them just now, so having them there is really important. They're also fairly reliable and resilient. Again, providing emergency resources to our grid is important, so it's there. The rapid response, similar to natural gas. Why do we have a problem with this, though? Why can't we just say, let's build new suppliers in this country? Why have we been working through a whole menu of solutions to try and fix this? Integrated markets. The previous picture also did show where markets are tied together. Many of the inverter companies that we talked to started with sort of one small product, and then they expanded up to be everything else. So when you looked at one of the companies, I think Sungrow is a good example just now. They're one of the biggest suppliers in the country, but they started out with one small inverter product and then escalated to also have EV chargers, other types of battery systems. They will sell a turnkey battery unit now as well. They basically escalate to sell everything at this point, and that's a really common model. When you look for one inverter or one transformer, you end up finding it all comes from the same company anyway as well. We also have some various issues on quality control. A lot of white labeling of inverters is happening as well. Again, that's white labeling sounds like the big scary word, but it's actually a common business practice here as well. There's one company recently that was supplying inverters for a different American company, and there was a contract dispute that happened, and as part of that contract dispute, because as it turns out, the Chinese inverter company was selling to everyone else as well, and that wasn't in their contract. As part of that contract dispute, they bricked the non-owned by them inverters as well. And there's a sign popped up saying, oh, by the way, you should probably contact your supplier. This wasn't meant to be there. It did show a couple of issues in that one, they could actually contact the inverters and brick them, meaning you could see that they had contact already. But it definitely highlighted that, we have this problem and we need to come up with better solutions. We also have contracts. Again, I'm not a lawyer, so I talk about contracts far more than I should. But contract negotiation is also one of the big things that we've been working on. People really do have fairly limited negotiation power with their Chinese suppliers just now as well. Those suppliers put things into contracts that mean you can't inspect the systems, you can't reverse engineer the software to take a look at what's in it as well, which is fairly common, but in this case, it'd be good for us to actually not have that in contracts so people could do inspection of the equipment and keep it operating. But in general, they're also fairly expensive to own. Buying a battery is not necessarily a cheap prospect, although the cost is coming down. If we did look at reshoring all of the power electronics just now, each one would probably cost in the realm of 50 to 60% more as a product as well. Tariffs not included in that just now, but it would still cost about 50 to 60% more to manufacture it here and install it. And that would still mean we needed the material to do it here. So we have a sort of growing problem. But rip and replace is something we hear pretty commonly for this. There was a statement, there was a couple of congressional reports saying essentially we need to rip and replace all of these Chinese systems. It's an interesting prospect, but one of the whack-a-mole picture is essentially saying if we get rid of 6 of them, there's a good chance we'll get another 73 that come right behind them that are just going to be there supplying the product. And in various cases, that product they supply might actually be inferior. Cattle and a few others have actually a really good safety record, or a good safety record as it comes to lithium-ion batteries, meaning they don't go on fire quite as much anymore, which is nice. Fire is pretty bad. So in the end, they don't go on fire quite as much. There are other products, though, sitting further down that list, which don't have that same safety record. They haven't been doing the research for the past 10 years on how to make these systems better or behave better or make more money, essentially. And so, getting rid of one product, we're just going to end up with potentially a bigger fire risk than we had in the first place. Also, I looked at the cost and timeline for doing this. For just our existing install base, which is around 23 gigawatts at the moment, would probably cost in the order of $10 billion, which if you look at what happened when we tried to replace Huawei, that was meant to be a $4 billion program to replace the Huawei products throughout our communication systems. It was underfunded by $3 billion, so until now, there still hasn't been a full replacement of Huawei because the most recent budget now has the $3 billion that was missing in it to try and help. It would also take about 4 to 10 years to replace because we actually don't have the product to replace it with. There isn't a US supplier that's going to just turn up and have 23 gigawatts available to put in place. It takes a while to build these things. So not necessarily the best, definitely would be a whack-a-mole process. So what we've really been looking at is how to secure around these components as well. So I had to get TikTok in here somewhere because I thought it was funny. But TikTok, what do these things have in common apart from being Chinese companies that we're looking to ban at the moment? It's been interesting watching the TikTok effort because there was the act that was meant to remove them. We're not meant to be looking at our cool TikTok dancing videos anymore. But interestingly, as that order came in, I think it was Sunday the 19th or 20th that order came in that this was it, we were done, and the weird notice came up on TikTok, not that I look at that ever. The notice came up saying it was banned. There was a great migration of all these influencers now saying, we're going over to this Red Note app, we're all gonna do this. It was everywhere, it was on the news. I'm looking at the Red Note app, just like, this seems bad. This seems really bad. What are you guys doing? And yeah, so basically we somewhat made a mistake, I believe, in my personal opinion, of forcing people onto something much less safe in the end. Much more control of the Chinese government was on that app than people realized, I think, right at the beginning. And again, we pushed people into something that wasn't necessarily the best choice, because again, similar to pushing people towards batteries that might go on fire, pushing people towards other applications, more things just pop up. Similar, Huawei, again, looked at the ban a number of years ago, but I think it was around 2019. Huawei also are a huge inverter supplier. So they were, I think it was 2019, they were number 2 in the entire world of inverter supply for the entire world. By 2022, so they exited the US market in 2019. They aren't at that big conference, by the way. They don't have a booth, as far as I know. But they aren't at the big conference, but by 2022, Huawei was number 1 in the inverter global market. They hadn't gone away, they were just globally everywhere. So again, banning them didn't necessarily give us what we thought it would. But now we do have an act looking at banning 6 different battery vendors from the country. Again, it includes CATL, a number of others. I'm not sure this has actually came through yet because, you know, we're in a little bit of change at the moment. But there has been a lot of talk of what are we going to do with these battery vendors when they supply almost everything. So again, back to the pushing people out of things tends to make them just go towards something else that's potentially more unsafe. So we need a better plan. As part of this work, this was work that we were completing working with CSER and the Grid Deployment Office in Department of Energy. We were looking at the full suite of solutions we have across, like not just Idaho Lab, but looking at the suite of solutions we could put together for this, that if we went and worked with these integrators and battery companies, what can we actually do to fix this rather than, you know, just say you probably need to get rid of that $10 billion of product. We needed to look at the systems. We couldn't just say we're going to go work with CATL and make them more secure. But there's no real fast path to getting there with domestic suppliers just now. So we put together an approach. We're using cyber-informed engineering, but looking at the full spread, technical, business operations, contracts, but also looking at how do we integrate every other solution, be it commercial, be it lab-based, be it any other lab as well. We were looking at what we could apply to this because a lot of us have worked on this for a long time. We do actually do things to fix it, but sometimes us getting them out there is not always our best. So what happens if you actually attack a battery is a question that people would ask, like, how bad could this be? Yeah, I don't do the fear, uncertainty, and doubt thing that often because I don't necessarily always believe we can cause the biggest thing people think. But in batteries, we have sort of interesting problems. There have been lots of remote monitoring cases. Remote monitoring is important for those systems, not just for safety, but for business operations as well. That's how they get revenue. It's really important. We could look at the asset health as well. I've mentioned fire. Interesting part, I'm also the daughter of a fire investigator, funnily enough. So interestingly, when things go on fire, my dad was always like, you know what burns things really well, but burns evidence? Fire. So like, actually knowing if something had a cyber attack in a fire is a very difficult prospect, to be honest, but they do go on fire in various ways. And then control grid impacts. We talked about there being about 23 gigawatts. Another kind of interesting feature being that we say that a lot of the batteries are doing ancillary services, meaning providing services to the grid on a normal operation. But they usually are able to do all the other things that are listed as potential options as well. So, you know, there's a number of options of how to have these items be controlled in a certain way with firmware or software manipulation. But that being said, there's a lot of ways to fix that. A lot of these things have low-hanging fruit solutions that we can work through. So yeah, we went through failure modes. You know, I had to say fire at least 10 times because it's me. But yeah, went through failure modes. But going on the solutions, these might not be a big enough font, but just to explain the solutions a little bit. When I mentioned the battery that was removed from the military base, and it's saying cattle on the tin behind the person's head, what's on the tin is actually fairly important for how we apply solutions. We do have a pretty healthy US integrator market, meaning the people that put their names on the tin as US companies. That's been growing in the last few years. It's a big opportunity to try and fix some of these problems. They might look the same on the inside. So what's on the inside and the outside counts in this case. On the inside, they might have the same OEM inverter, same cells, same battery management system. It could look exactly the same, in lots of cases they do from a hardware perspective. But on the outside and in the software around that, that's where we have options. We have ways that we can work on secure design packages for those. The one example I wanted to give a lot was the use of firmware delivery and data delivery. These things do need firmware updates quite frequently. There's a lot that goes on in that space. The other thing that battery companies also need quite a lot of is data. I mentioned the fire risk improving over the last few years. Partially that's because these companies get data from all of these products and then use that to improve their safety. A lot of people send it direct from the product, but there is a way that you could route that through a different point and reduce that risk and still give them the data that they do need to maintain the safety of their batteries and improve them over time, but not create a direct connection to your network as well. And that's solutions that we have. When you work with the US integrators, we can help with those solutions. They can put those solutions in place as well. But when you look at the PRC integrators, essentially that's where we have a little more of a problem. Things to do with where the data goes, who gets the data, what's installed. There are still ways to work with these systems, again, but there's a higher risk there, and that's sort of how we portioned out these solutions as well. So technical risk. Inverters all have issues. It doesn't matter where they're made. That's the power electronics, and generally all have some form of issue at the moment. They weren't necessarily designed to be secure to begin with. They were designed to be functional, not necessarily secure and functional. So they have some features in the original designs that are just not great to do with things like hard-coded passwords, funnily enough, direction for firmware connections, mass orchestration, service control retained by OEM is an interesting one, meaning when you don't buy the service from them, I mentioned the bricking event. If you're not buying the service from them, they can turn it off. So. And then bad documentation or no S-bombs or H-bombs. Basically, bad documentation is really common. Fairly frequently, I get handed a data sheet the other day just in Chinese. I don't know which version. I don't speak it. But I was like, how's anyone going to work? How am I going to work with this? I don't have a translator right now, so it's kind of hard. Standards is also a big area that's been worked on. Challenge being, so one of the big standards for inverters is IEEE 1547. There was a new cybersecurity version of that came last year. Problem being, though, that standards take a long time to implement. Most of the inverter companies recently implemented IEEE 1547 2018, which is great. We're in 2025. So with one being brought in last year, there's a good chance we might not see that really be in place for a number of years. And even then, it would take the states and others forcing this into interconnect agreements for people to actually start adopting it. So organizational risk is one we worked on as well. This is a site that or a set of sites we were looking at to give the example of who do you even work with or who do you call if you have a problem. We started out looking at one, and again, it's a real site. I've just removed most names for obvious reasons. But we were looking at a developer, we'll call them Developer 1, and they had bought the interconnection slot, so they were going to develop the site. They decided to sell the sites to another company, we'll call them the finance company, In looking at them, I actually called them the Finance Bro Company, but they had bought about 800 megawatts of generation from these sites. And then they developed the sites from there. They hadn't even built it yet, but they developed the site using, I believe, Cattle as the integrator, so they had the same structure for 800 megawatts across the whole place. The developer was then bought out by another owner at this point, so now we've got, I think, 3 or 4 different owners in a period of 2 years, so we're trying to work out who's the asset owner at this point. And then where this was actually connected was important, because the interconnect studies that were done for where the actual physical point of where the electrons would go, there was a number of co-ops and munis that had done power purchase agreements with these entities, so while they were physically connected to those events, they were just buying the power, so they weren't actually in charge of any of the security components on this. So this is really complicated, as it turns out, trying to work out who you would actually talk to fix any of this. The other interesting piece with the integrator was there was a 4th-party operations and management entity in Texas that was coordinating and aggregating a lot of these resources. And then they were connected to to ERCOT, essentially, at that point, through fiber for the market as well. So the number of points of connection that we were trying to work out for this relationship here was insane, to be honest. Like, all these people that had bought and sold different components, all these historical decisions that were made were hard and challenging to work through. Who would we actually talk to try and fix this? Who would you talk to if there was an event as well on this system? If you thought there was a cyber event, who would you actually call in this whole suite of people as well? So we put together a menu of solutions. I called it along the integrator scale of risk here, where we went from PRC-owned, operated, connected systems, which is a lot of the actual installed base currently, moving through to the emerging design, and then up to future, where we have this US operated and connected. Originally had a unicorn picture in here, or a mythical creature up on the top right, because there really isn't any full US-owned, operated, and connected systems at this point. It's actually partially why this project got the name Bessie originally, because it's a mythical creature. Bessie, Nessie, get it? Yeah. But we looked through, again, suite of solutions here of things that we needed to do from policy and technical perspectives as well. One of them being getting the right to inspect for these systems for vulnerability, because right now we don't get the right to inspect any of these systems in the contracts. You can't go through them. Looked at, again, I'm not going to read them all out because you can read a slide, but we looked at the whole raft of solutions we could put together and did put this all together into a report and shared it out publicly as well for people to use. And then actually worked out the partners that we would work with as well. But this isn't actually all theoretical. We are actually doing this now with deploying the solutions. It's been going on for the last year. We're getting the solutions out into the field, working with many different entities, some of whom are here today as well. We're trying to get these rapidly out there so we can actually fix this in the next couple of years, not actually so that we just end up with another problem in 2 years that we didn't fund the rip and replace for the whole system. We've been working with a lot of the federal awardees of the last couple of years to actually enhance how they install the systems, how they make contract decisions. We have about 15 deployments planned to about $20 billion of infrastructure at the moment of our security efforts that are there as well. We're prioritizing locations, because there are locations where replacing those systems is probably a good idea, actually, but there's other ones where it's not. Again, consequence prioritization being the point here. We've looked at a CIE tool and training, and I'll talk about that in a second. We have cohorts of integrators working together, the US integrators, to help improve this as well. And then we have sort of policy changes that we've been working on as well, of helping people get to allow that inspection. So we released a procurement guide and contracting guide that says, here's some language you can X out. If you can get the whole country to X that out, maybe we get some power back from those integrators as well. So how to get that in there was really important to me as well. But some of the things we've been working on that are real, that you can download, use, whatever. We put together a cyber-informed engineering design guide. This isn't just a sort of esoteric, here's what you could maybe do. There is actually a straight-up list of things that you can actually do, that you can prioritize through the system. Again, starting from the consequences that we work with, essentially saying what is the worst case scenario, and then going through and doing the consequence analysis and putting those mitigations in place, or planning to put them in place for your new designs in future as well. One of the cool ones that we did was hunting Bessie. So we put together a hunt kit, essentially, that the teams can go out. Like, they've got a kit integrated. We have a team that goes out and works through the systems and looks for any evidence of activity, looks for the worst case scenarios that are happening, looks for what's talking to what, and then tells people what probably here's the low-hanging fruit of what you can fix at this point, and also helps us aggregate what other risks are we seeing that we didn't catch in this initial analysis as well. They've been out there doing that, again, hunting Bessie. There are stickers for the Bessie logo as well, so don't rush me too hard here. But there are stickers, so we have this team out. They've been out to a number of sites already, and the idea is that they can also help configure these things for future as well. I mentioned earlier the fire safety as well. That one's important to me. Well, it's all important, but this one is very important. Fire engineering is really interesting. It's not necessarily a cyber mitigation for the biggest consequence in the end. If a battery does go on fire, there's very little you can actually do to save a lot of parts of the system. But you can actually stop it becoming a giant bomb, which is nice. Basically, when batteries go on fire, there's a lot of gas that comes off of that. That gas is horrifically flammable, and if it gets contained inside a container and doesn't vent out, it's pretty dangerous for anyone that's anywhere near it, in particular firefighters and others that are trying to help save this system. So one of the things we're doing when we're going out to sites is also making sure people have got designs like the vents are in the right place, because a number of systems that came in just didn't have vents in the right place, which is important. Those vents are also manual, which is awesome because nothing is controlling them. They pop up themselves. Manual vents, here you go. The other piece was looking at, PNNL have done some really interesting work as well on alternate sensing, because one of the challenges we were worried about was, what if the sensors are failing or somebody is messing with the sensors so you don't know it's going on fire? And there's an alternate sensing package that was worked on to put on the most highest consequence systems as well, so that you can deploy that and look at those. Again, I mentioned secure information architecture. We're looking at, in the guide that we have, of how to make sure that data that the company does need is put to the right place and isn't connected live into your network as well. And lastly, last year, this isn't all the things. I'm not going to read out the 92 mitigations you could possibly use. You can read the report. Last year I ran a Birds of a Feather Room, ran a little exercise called Sunsplat in the end. We had a different name, but Sunsplat was what everyone caught onto, so it stayed. Someone even made me this picture during the exercise. But Sunsplat was meant to be an exercise that was helping with who actually talks to who if there's an event happening, how do you put your incident response plan together to account for these resources you maybe don't own and don't know what to do with, but still have a physical effect on your system. We have an IR guide, incident response guide, coming out that integrates these components as well. And also just working and talking to the fire and incident responders and what they actually do. One thing I hope never happens, I don't want any cyber incident responders going anywhere near a battery fire ever. Please do not do that. Don't walk in there. Just let it burn. But at the same time, we want to work with fire and incident responders, so if there's any chance of something to be taken out of that site, we can get that done because we're not having you all going out there. So key takeaways, rip and replace is kind of a big distraction. Everyone got very excited about it for a while. It's really a big distraction, and we really want people to actually do the right thing rather than worry about the big esoteric thing they can't actually fix. We can't fix everything, though. There will still be risk. These are still systems we might have worries about, but we can actually make it harder. We can get rid of the low-hanging fruit. We are working with lots of entities to do this. This isn't just the lab is doing something. Lots of entities, partners, subcontractors helping us get these things out there. We're having people work with us all over the place to get this out there. But partnership has been really important. Understanding all of those relationships coming together wasn't just a one-person job. There was a huge team, basically. Each person knew a different part of this before we pulled it all together. So it's been really important. We've got this work going out there. We're really excited about it, but I thank you for listening to me talk about it today. So thank you.